And now for some examples using a geometric mean. Well, if I'm going to be using a geometric mean, I would like to at least have a diagram that's going to help me a little bit. So I'm going to copy out this diagram. We call this X, we call this Y, we call this C, we call this A, we call this B, and we call this H. And we know that H squared is equal to X times Y. We also know that A squared is equal to X times C. And then obviously B, same idea will work. All right, so step one, write a similarity statement comparing three triangles. Well, sometimes it's a little bit easier to draw all the triangles oriented the same way. I'm not going to redraw the large one because it's already there. Let's take the second largest. And I will draw it in the same direction that it's drawn here, the large triangle is drawn here. We know that this is Z, because that's where the right angle is occurring. The point is still at U, and that makes this W. And let's draw the smallest. Right angle's here. That is at point Z. The tip is at W, and we have V. So this makes it a lot easier. So we know that triangle UWV is similar to triangle UZW, which is similar to triangle WZV. And that's just the easiest way to do it. Okay, example 2, finding geometric means. All right, the geometric mean, it means we need to multiply those together. So let's call it the geometric mean x. So x squared is equal to 4 times 25. X squared is equal to 100. So x is equal to 10. We can throw out the negative because obviously negative 10 is not between those two. Same idea. X squared is equal to 5 times 30. X squared is equal to 150. Square root. So I get x is equal to, well, this can be broken apart into the square root of 25 times the square root of 6. That's 5. I can't do anything with that. So x is equal to 5 root 6. All right, now for the problem I was worried about forgetting how to do. So let's start with, well, we can find x easy enough. So we know that 6 squared is going to be equal to x times 9. Okay, we'll see 6 squared. I'm just using this rule right here. 6 squared is 36. We have 9x, divide by 9, and we get 4 is equal to x. All right, so if that's 4, I can work the same way to figure out y. So I know that y squared is going to be equal to this side length here, 4, times this entire side length, which is 13. So 4 times 13 is going to be 12, carry the 1, so that's 52. So y squared is equal to 52. So square root. Now 4 goes into 52. So we have the square root of 4 times the square root of 1, carry the 3, carry the 1, and that would be 3. And so y is equal to 2 root 13. Have a great day. And that leaves z. Well, I'm going to use this rule right here. So that means z squared is going to be equal to 9 times the whole thing, which is 13. So z squared is equal to 9 times 13. So 9 times 3 is 27. Carry the 2, so 117. So square root. And shockingly, 9 goes into it, and it's just going to be 3 root 13. Finally, let's find the height of the Rockefeller Christmas tree, which is clearly this distance right here. Good morning. Well, we know this is 1.6. We know this is 7.8. So we know that, well, what do we know? Well, we could find this side length using the Pythagorean theorem. But we don't need that because we know that using the geometric mean, the height squared is equal to this side times this side. All right, so 1.6 times x. The height is 7.8. I don't know 7.8 squared off the top of my head. So 7.8 squared. And I'm going to now divide it by 1.6. And so the height is 38 meters. That is a really tall tree. Seems somewhat unrealistic. Anyways, it's a math problem. So there we go. So that's how we go through these examples and how to use the geometric mean. And good luck.